Section 1.5 continued. Absolute value inequalities. Let k represent a positive real number. Here we have the absolute value of x is greater than or equal to k. Let's say that would be the absolute value of x is greater than or equal to 3. That means that x can be any value greater than 3 and also any value less than 3, because when you take the absolute value of it, that will work into our solution. Therefore, when I have the arrow pointing to the right, the absolute value of x greater than or equal to k represents a union for a solution and also when I graph. Therefore, a union is all solutions that are shared and non-shared by our inequalities. The absolute value of x is less than or equal to k. Again, I could set an example of x is less than or equal to 2. In this situation, all values of x can be between a 2 and negative 2. Therefore, this would be shared inequalities, or in other words, an intersection. So greater than or equal to is going to be a union when I graph, and also for the solution. And less than or equal to is going to be an intersection when I graph and for its solution. Let's look at the procedure to solve absolute value inequalities. Here we want to copy the problem. 2, use inverse operation to get the absolute value expression alone on one side of the equation. Number 3, use the expression inside the absolute value and its inequality to the solution to make the first inequality. Then we want to use the expression again, flip the inequality, and then use that with the negative value of the solution for the second inequality. Then we want to solve each inequality as in the previous sections. Also recall that we want to use an intersection or a union depending on this definition. Let's look at an example. The absolute value of 2x plus 5 is greater than 3. Here the absolute value is greater than 3, therefore this is a union, also known as OR. Let's solve the problem. We copied it. Now let's set the expression 2x plus 5 and its inequality to 3. And let's use 2x plus 5. Again, flip the inequality and make the solution negative. Solve each inequality separately. Subtract 5 on both sides. That gives me 2x is greater than a negative 2. Divide by 2 on both sides. X is greater than a negative 1. Or subtract 5 on both sides. That gives me 2x is less than a negative 8. Divide by 2. That gives me x less than a negative 4. So my solution, x is greater than a negative 1 or x is less than a negative 4. Graphing, we have an open point at negative 1. Shade all values of x that are greater than that, so that would be to the right. At negative 4, I have an open point, and all values of x that are less than that, so we shade to the left. Our next example, a negative 2 times the absolute value of x plus 1 plus 5 is greater than or equal to a negative 3. We have to get our absolute value expression alone on one side. So let's start by subtracting 5 on both sides. That gives me a negative 2 times the absolute value of x plus 1 is greater than or equal to a negative 8. Divide both sides by a negative 2. It gives me the absolute value of x plus 1, and my solution on the right is a negative 8 divided by a negative 2 is going to be a positive 4. But recall, from the properties of inequality, when I multiply or divide by a negative, that changes my inequality, and that means I flip it, and that becomes less than or equal to. From our definition, the absolute value is less than 4. Therefore, this is an AND, which is an intersection. Let's set the expression x plus 1 less than or equal to 4, and x plus 1, flipping the symbol, greater than or equal to negative 4. Solving each one separately, subtract 1 on both sides. X is less than or equal to 3. And subtract 1 on both sides. X is greater than or equal to a negative 5. Let's graph. This is going to be a closed point at negative 5 and a closed point at 3. Values less than 3 go to the left, and values greater than or equal to a negative 5. Remember, we only want the ones that are shared, not the ones beyond 3 and negative 5. So we can combine this as a compound inequality and would look something like this. X is less than or equal to 3, and x is greater than or equal to a negative 5. Another example, the absolute value of x minus 3 is less than 5. The absolute value is less than 5, therefore this is an and, also known as an intersection. Let's solve. Set the expression x minus 3 less than 5 and x minus 3. Flip the inequality, makes it greater than, and a negative 5. Solve each one, add 3 to both sides. X is less than 8. Add 3 to both sides. X is greater than negative 2. Let's graph the solution. Values of x greater than a negative 2. We could show this off the line, and then we'll graph it on the line, but we'll just set it up as an example. Open point at negative 2, values of x greater than. And less than 8, again, open point at 8. Values of x less than 8. And then we actually want to show the solution, which remember, and is an intersection, so we want the shared points. But we have a closed point on the green, but not the red, so this would be an open point at negative 2. Similar situation at 8. And all values shared by the green and red line, which are values in between 8 and negative 2. We can show this as a compound inequality. X less than 8 and x greater than negative 2. You can use absolute value inequalities and compound inequalities to specify allowable ranges in measurement. For example, a tolerance. A tolerance equals 1/2 of the difference between the maximum and minimum value. Let's take a look at an example. Here, the area A in square centimeters of a picture is required to satisfy a range. Our range is where our area has to be less than or equal to 7.8 centimeters or greater than or equal to 7.4 centimeters. They want us to write this requirement as an absolute value. This is the procedure you can follow. Find the tolerance. The previous slide showed us that is the difference between our max and min, and then divide by 2, which gives us 0.4 divided by 2, which is 0.2. Find the average of the max and min. Well, to find the average of the max and min, we add them together and divide by 2, which is 7.6. Write it as an inequality. Our area minus 7.6, and then we set that up inside of our tolerance. Less than or equal to the positive value, greater than or equal to the negative value. Then we just write our expression inside of an absolute value as less than or equal to 0.2. And remember, if we solve this, we set the expression a minus 7.6 less than or equal to 0.2, or we set our expression a minus 7.6 greater than or equal to the negative value. And notice when I solve for a will fall in between my range of 7.4 and 7.8.